Hello, this is Rick Reardon. In this video lecture, we're going to explain the finer points of correlation and introduce you to inferential statistics. Okay, we're going to talk about accuracy, sensitivity, specificity, chi-squared, and inferential statistics and the relation of correlation. When we talk about accuracy, we're basically talking about the number of accurate, correct predictions divided by the total number of predictions, and give you this formula as is illustrated in example 6.5 of your textbook. This is an important concept to get around. It's almost like your grade on a quiz. If you have a quiz of 10 questions and you've gotten 9 of them right, you have 9 divided 10 is 0.9, or in percent, 90%. When we talk about sensitivity, this is in chapter 6, talking about sensitivity, specificity. And they're related, but not the same. When we're talking about the positive rate, we're talking about the sensitivity. And this is in example 6.2, which is talking about employees and parents smoking, to talk about the association between the two variables. When we talk about specificity, however, we're talking about the proportion of subjects without the condition. In other words, the number of false positives. And we can calculate that by taking the total number plus the total number plus divide by the total number plus the false positives. So in the example in your book in chapter 6, we have the true negatives of 50, right, of employees whose parents do not smoke, who also don't smoke. And then the false positives are 25. So if we take those 50 and divide 50 plus 25, we wind up with 0.66.7. So this indicates 66.7% of employees whose parents do not smoke also do not smoke. And then the chi-squared test. We're really not going to dive into the weeds on this. This is in a biostats class, but the chi-squared test of independence tests for relationships between categorical variables. It's looking at whether an association exists or if the variables are truly independent. And when we take a look at correlation a little bit later, it'll become clear, as we'll have some charts that will illustrate that. When do we use chi-square? We use it in health services research. We use it when we're analyzing 2x2 tables with categorical data sets. So now we get into correlation. What is correlation? Correlation basically measures the relationship between two variables. It's indicating how they move together. It does not imply that one variable causes changes in another. It's only saying that they're associated. And we'll talk more about that when we talk about correlation and causation. So there's several different types of correlation. We can have a positive correlation where both variables move in the same direction. So an example is the higher one's education level is, it's associated with higher income. We can also have a negative correlation. So one variable increases while the other one decreases. So increased exercise and lower body weight. And then we can also have no correlation. So this is basically dots all over the place with two sets of variables. Let's take a closer look at what these charts look like. Now you can see here we have variables, and this could be PSA scores and the rate of male prostate cancer, but you can see a positive correlation. Generally, as PSA scores go up, a male patient is more likely to have prostate cancer. And you can see the dots, right? your basic XY dot. But when we take a bunch of observations and plot the incidence of cancer with the PSA level, we see a positive correlation. We see something similar with higher education levels and higher incomes. We could also have a negative correlation, right? So this is a strong negative correlation. We use the example of increased exercise as one variable and decreased body weight. And then here's just kind of a summary of these. We can have different degrees of strong positive correlation. We can have a weak positive correlation, strong negative, weak negative, moderate negative, or in the lower right-hand corner, you can see no correlation. Now, are you ready to try some calculations correlation? This is one of the easier things to do. I put an example here on Moodle, so this is optional, but you can download this Excel file and then type in the formula that's shown on the next side. And here's an example of how we use this. We're looking at the number of phone calls per week to make an appointment to see a new psychologist. So X is the number of phone calls. We're going to plot that. And then we're going to have Y, the number of actual visits to the psychologist plus any walk-ins. And what you can do is create an Excel sheet that uses a CORREL function to calculate the correlation between the number of appointment calls and the number of actual visits. And of course, you have to get both the range as illustrated here. So in column A, we have the number of phone calls per week over a series of weeks, 5, 6, what have you. We go CORREL. We put in the parentheses both ranges separated by a comma, as you can see here. So what does it mean? We wound up with a correlation, and normally this is referred to as R of 0.97. If it was a perfect correlation, it would be 1.0. So this is a very strong positive correlation. And if you think about it, it makes sense. There's a strong linear relationship, and if we chart it, it would be that looking like one of those charts that shows a strong relationship between the number of appointments made, number of calls, if you will, and the number of actual visits. So is it always the case with correlation? Well, just because two variables are correlated doesn't mean that one causes the other. There needs to be a cause. So if we're looking at a correlation between two factors, we have to look at what's going on. So, and take action, actually do some research. And we use the example here of people who drink water tend to have healthier skin. That's a correlation. We also know that proper hydration causes people to have healthy skin. So that's the causation. And here's a spurious one. This is just something that I found in the files on rooster.com. And there's an example between the number of films that Nicolas Cage appears in each year and the number of swimming pool drownings in the United States. Statistically, there's a strong correlation, but logically, these things are not connected. So things can be purely coincidental, as is the case here, or they can be caused by something entirely unrelated. And that kind of leads us to inferential statistics. These types of inferential statistics allow us to take a sample because we can't look at literally everything, and we can make inferences about a population. And the main way that we do this frequently is by analyzing relationships between variables. And this is one of the things that supports such things that we see in healthcare, like evidence-based decisions, evidence-based medicine, etc. I hope you all found that useful. Please reach out to me if you have any questions about the topics that were covered in this lecture. Bye now.